Hello and welcome to our Unit 5 FRQ videos. The unit is on momentum, and so let's get started. Alright, so the first question asks, a boy whose mass is 42 kilograms runs at 5 meters per second and jumps onto a 10 kilogram stationary sled. The boy slides on the sled over a horizontal frictionless surface at a speed of whatever. And so I've gone ahead and drawn out the scenario for you. So we have the boy over here, 42 kilograms, and is going at a speed of 5 meters per second. He jumps onto a sled, which is stationary and weighs 10 kilograms. And then afterwards you have a boy on a sled who's going at the velocity that we're trying to solve for. Alright, and so the way you want to look at this is you want to look at this as a classic momentum problem in which you have an initial set of momentum equaling a final set because of the law of conservation of momentum. So let me write this out. So m1 v1 equals m2 v2. That is the formula for the law of conservation of momentum. Basically says what happens here in the beginning should equal the momentum in the second part. And so let's rewrite this to calculate everything. So let's just say m1 is equal to 42. Alright, so m1 times v1, which would be this velocity, is equal to m2. Okay, so for m2, you can't just say it's the sled, or you can't just say it's the boy. If you look at this picture, the second mass is going to be the kid on the sled. So you're going to want to add these two up together. And so this will equal m2. And then velocity 2 is what we're trying to solve for. What is the final velocity? Alright, and so now we have our equations kind of set up, and now we just have to plug in. So you get m1, which is 42, times v1, which is 5. Oh, I didn't write this out. v2. Alright, and that equals these two combined, which was 52, times v2. And then when you do the calculations, you do 42 times 5 divided by 52. You get v2 equals to 4.04 meters per second. And as for why this makes sense, well, if he's jumping onto a sled, obviously he's going to slow down a little bit, and so this is a little bit less than what he started off with. And there you go.